Slope-intercept form. Another very useful form of the equation of a line is the slope-intercept form. It's based on the use of the slope and the y-intercept of a line, hence the name. Similar to point slope, we are going to start by showing a derivation proof of slope-intercept form. So let's start with the definition of a slope in which 2 points on a line are given by the ordered pairs of x1, y1 and x2, y2. So we have m equals y2 minus y1 over x2 minus x1. As a first step, let's just name the coordinates for the second point xy rather than x2, y2. So that will be true for any point on the line, not just one point, and will allow us to write an equation for all points on the line. So then our slope formula becomes m equals y minus y1 over x minus x1. Now let's solve that equation for y using what we've learned about solving equations. So let's try it first before we go further with our answer. Let's think about what we would have to do to solve for y. So the first thing is to remember to think that the denominator of x minus x1 is in parentheses. So we can think that what's happening to the variable y? Well, it's being subtracted by y1 and divided by that quantity of x minus x1. So those are the operations we're going to have to undo to get that y variable isolated or solved for. So we will multiply both sides by that quantity of x minus x1 to get rid of the fraction. So if we do that here, we have to do it to both sides of the equation. So that will leave us with m times the quantity of x minus x1 equals y minus y1. Now let's add y1 to both sides. So that will give us that m times the quantity of x minus x1 plus y1 now equals just y. And if we switch the sides, we've accomplished our goal. We have y equals m times the quantity of x minus x1 plus y1 as our equation. And this is fine and allows us to graph a line given any point x1 and y1. But one additional step is taken to get the most useful equation for a line. So if we use specifically the y-intercept for x1, y1, then the y-intercept is the point where the line crosses the y-axis, and we'll have the coordinates of 0, b. So that means x is 0 anywhere on the y-axis, so that's just a fact. So it's the definition of our y-intercept, and we're just naming the y-intercept that y value b. And if we substitute in x1 is 0, then x minus x1 is just x, and then the y1 would be b. So our equation becomes y equals mx plus b, which is the most popular way of seeing slope-intercept form. So slope-intercept form, y equals mx plus b, is where m is the slope, so it's that coefficient of x, and b is the y-intercept. It's the point of 0, b. That's the constant in the equation. And then xy is any of the infinite points that satisfy the equation. Slope-intercept form is the form of the equation of a line that is most often used. If you are provided a graph of a line, you can calculate the slope m and then read b, the y-intercept, directly from the graph. That allows you to write the equation of the line directly, which you can then use to find any other needed points. So let's take a look at that in an example. So here we have our line in the coordinate plane here, and it has a y-intercept at the point of 0, -2, and we know that because that's the point where the line is crossing the y-axis. And then we can count that there's a slope of 3/4. To go from point to point on the line, you're going up 3 and right 4. So with that y-intercept and that slope, we can have the equation of the line be y equals 3/4 x minus 2, substituting in the values of mx and b in y equals mx plus b. Here's another example. We have our line graphed, and we have first a slope of 1 over 1, because going from each point, we're going up one, right one, up one, right one, up one, right one. So the y-intercept is 0, 0, because that's where the line is crossing the y-axis. So b is 0, m is 1. So therefore, our equation y equals mx plus b would be y equals 1x plus 0, which we can then simplify to just y equals x. Another example, we have our line here graphed, and here we can see the slope of the line is 1/5. If we go from this point to this point to this point, any point to point on the line, we're going up 1, right 5, up 1, right 5, and we continue to go up 1, right 5. So m equals 1/5. The y-intercept is 0, 3. We can see that's where the line is crossing the y-axis. So therefore, the equation of the line in slope-intercept form is y equals 1/5 x plus 3, coming from the y equals mx plus b. Here's a different example. Here's one where we have a negative slope, right? This line, if we go from point to point on this line, we're going down 2, right 1, down 2, right 1, down 2, right 1. We also could be going up 2 or left 1, up 2, left 1, which is the same slope. That just gives you 2 over -1. No matter what way you look at it, your m value is now -2 from the slope. The y-intercept, we can see the line is crossing the y-axis at 0, 1, so b is going to equal 1. So therefore, the equation of the line in slope-intercept form is y equals mx plus b. Substituting in our values, we get y equals -2x minus 1. Or plus 1. It should be plus 1 because it's positive. B is positive 1 plus 1. Right? Make sure you watch your signs and don't get fooled. And then finally, here we have a horizontal line. We know that horizontal lines have a slope of 0. And we can see that the y-intercept, the line is crossing the y-axis at 0, 4. So our slope is 0. That means m equals 0. Our y-intercept is 4, so b equals 4. So therefore, the equation of the line in slope-intercept form, y equals mx plus b, is going to be y equals 0x plus 4, but we can simplify that directly to just y equals 4. And this matches that horizontal lines, you should only see that y variable because of that slope of 0 is making the slope, the x term, disappear. So using slope-intercept form, we can write the equation of any of these lines as you saw, as long as we have the graph where we can find the slope and look at the y-intercept.